Picture this. You wake up tomorrow morning, check your phone for the weather, and instead of seeing partly cloudy in New York, you're looking at the forecast for the coastal regions of Pangaea. That's right. What if I told you that in an alternate reality, the supercontinent that existed 335 million years ago never broke apart? What if Africa and South America were still kissing at their eastern and western shores? What if you could literally walk from London to Tokyo without ever seeing an ocean? Tonight, we're diving into one of the most mind-bending what-if scenarios our planet has ever faced. And trust me, by the end of this exploration, you'll never look at a world map the same way again. Before we get started, I need to know where you're listening from. Drop a comment and tell me your city, because what I'm about to reveal will completely change how you think about your location on this planet. Are you in what we call North America? Well, in our alternate Earth, you might be neighbours with someone from what we now call North Africa. Mind-blowing, right? Here's what most people don't realise about continental drift. It wasn't just some gentle, slow-motion dance of land masses. It was a violent, earth-shattering process that literally tore our world apart over hundreds of millions of years. But what if those massive tectonic forces had never gained enough momentum? What if the supercontinent of Pangaea had remained locked together like pieces of an unbreakable puzzle? I'm about to take you on a journey through an Earth so different, so alien, that it might as well be another planet entirely. We're talking about a world where the very concept of crossing the ocean doesn't exist, where evolution took paths so bizarre that the animals and plants around you would be unrecognizable, where human civilization, if it even existed, would have developed in ways that defy everything we know about history, culture, and geography. And here's the kicker. This isn't just some fantasy scenario I'm making up. Scientists have actually studied what our planet would look like if Pangaea had never split. The results? They're absolutely staggering. We're talking about climate patterns that would make today's weather look tame. Ocean currents that would create massive dead zones and tropical paradises in places you'd never expect. Mountain ranges that would dwarf the Himalayas, and ecosystems so unique that they'd make the Amazon rainforest look like a backyard garden. But before we dive into this alternate Earth, let me paint you a picture of what we're actually dealing with here. Imagine taking every single piece of land on our planet right now, every continent, every island, every bit of solid ground, and smashing it all together into one massive landmass. That's Pangaea. It was so enormous that if you stood in the centre of it, you'd be thousands of miles away from the nearest ocean in any direction. Now, here's where it gets really interesting. The forces that split Pangaea apart weren't random. They were driven by convection currents deep within the Earth's mantle, massive flows of molten rock that created pressure points and weak spots in the supercontinent's crust. But what if those convection currents had been different? What if the Earth's internal heat engine had operated in a completely different way? Scientists believe that if just a few key variables had been altered, Pangaea could have remained intact indefinitely. Maybe the mantle plumes that created hotspots under the continent had been positioned differently. Maybe the subduction zones that pulled oceanic crust down into the mantle had been less active. Maybe the very composition of the Earth's core had been slightly different, creating weaker convection patterns. The point is, our world of separated continents isn't inevitable. It's the result of a specific set of geological conditions that could have played out very differently. And when you start to imagine what that different world would look like, things get wild really fast. Let's start with the most obvious change: climate. On our Earth, ocean currents act like a massive global air conditioning system, moving warm water from the tropics toward the poles and cold water in the opposite direction. This circulation pattern is what keeps places like Western Europe habitable, despite being at the same latitude as frozen parts of Canada. But on Pangaea, this entire system would be completely different. Picture this massive supercontinent surrounded by one enormous ocean called Panthalassa. Without the complex network of currents we have today, moving heat around the planet would be far more difficult. The interior of Pangaea, thousands of miles from any ocean, would experience some of the most extreme continental climate conditions ever seen on Earth. We're talking about temperature swings that would make the difference between summer and winter in Montana look like a gentle spring day. The center of Pangaea would be a massive desert, hotter than the Sahara in summer and colder than Siberia in winter. Rainfall would be virtually non-existent in these interior regions because moisture-carrying winds from the ocean wouldn't be able to penetrate that far inland. But here's where it gets even more fascinating. The coastal regions of this supercontinent would be completely different too. With only one massive ocean surrounding the landmass, the seasonal patterns would create monsoons of unprecedented scale. Imagine walls of rain that would make today's hurricanes look like light showers, seasonal floods that would reshape entire landscapes, and coastal storms that would be visible from space. The weather patterns alone would create a world so hostile in some regions and so lush in others that the very concept of global human civilization might be impossible. You'd have vast interior wastelands where nothing could survive, surrounded by narrow coastal strips where life would flourish in ways we can barely imagine. And that's just the beginning. Let's talk about what this would mean for evolution itself. On our Earth, when Pangaea split apart, it created isolated environments where species could evolve in completely different directions. That's why Australia has marsupials, why Madagascar has lemurs, why islands often have unique species found nowhere else on Earth. But on our alternate Earth, with all land masses connected, evolution would have taken a completely different path. Instead of isolated pockets of unique species, you'd have massive continental ecosystems where the fittest species would dominate enormous territories. Imagine predators that could range across areas the size of entire continents, following massive herds of prey animals through migrations that would span thousands of miles. The biodiversity we see today, with its incredible variety of species adapted to specific local conditions, simply wouldn't exist. Instead, you'd have a smaller number of highly successful species that had conquered vast territories. It would be like having the entire planet dominated by the biological equivalent of Walmart. Massive, efficient, but ultimately less diverse than the small local businesses we've lost. But here's the really mind-bending part. These continental-scale ecosystems would create evolutionary pressures, unlike anything we see today. Animals would need to be incredibly adaptable to survive in environments that could span from tropical coastal regions to frigid interior deserts. We might have seen the evolution of species with migration patterns covering half the planet, creatures that could survive in multiple climate zones, possibly even animals that could hibernate for months or years to survive the extreme seasonal variations in Pangaea's interior. Think about it. What would a predator look like if it had evolved to hunt across an entire continent? What would a plant species look like if it had to survive in conditions ranging from coastal tropical zones to interior Arctic deserts? These wouldn't just be different species, they'd be different forms of life entirely. And then there's the question of whether intelligent life would have even evolved at all. Human evolution was driven partly by environmental pressures created by climate change and geographic isolation. Our ancestors had to adapt to changing conditions as forests gave way to savannas, as ice ages came and went, as rising and falling sea levels connected and separated different populations. On Pangaea, many of these pressures wouldn't have existed. The massive interior deserts might have been so hostile that complex life never gained a foothold there. The coastal regions might have been so stable and abundant that there was never evolutionary pressure to develop higher intelligence. Or maybe the continental scale environmental challenges would have created completely different forms of intelligence. Creatures adapted to think on scales of time and space that we can't even comprehend. Imagine a species that had to plan migrations lasting decades, or creatures that had to coordinate behavior across thousands of miles, or life forms that had to adapt to environmental cycles lasting centuries. These wouldn't just be smart animals, they'd be forms of intelligence, so alien to us that we might not even recognize them as intelligent. But let's assume for a moment that some form of intelligent life did evolve on this alternate Earth. What would their civilization look like? This is where things get really interesting, because the very foundations of human society, everything from agriculture to trade to warfare, would be completely different. On our Earth, civilizations developed around rivers, coasts, and fertile valleys, often separated by natural barriers like mountains, oceans, or deserts. This geographic isolation led to the development of different cultures, languages, technologies, and social systems. The diversity of human civilization is largely a product of geographic separation. But on Pangaea, there would be no natural barriers preventing the spread of ideas, technologies, or people. A successful innovation in one region could potentially spread across the entire continent within a few generations. This could lead to incredibly rapid technological development, as the best ideas from everywhere would quickly become available everywhere. On the other hand, it could also lead to stagnation. Without the competitive pressure that comes from isolated groups developing different solutions to similar problems, there might be less innovation overall. Why develop a better tool when the current one works fine and there's no competing civilization pushing you to improve? The social implications would be staggering. Could a single government control an entire planet-spanning continent? Would there be massive empires covering areas larger than any we've ever seen? Or would the sheer scale make centralized control impossible, leading to a patchwork of smaller societies connected by trade networks spanning half the planet? And what about resources? On our Earth, the separation of continents created scarcity and abundance in different regions, driving trade and exploration. But on Pangaea, depending on how resources were distributed, you might have completely different economic systems. Maybe the coastal regions would be incredibly wealthy while the interior remained permanently impoverished. Maybe there would be massive resource gradients that would create the largest wealth gaps in history. The more you think about it, the more you realize that this isn't just a question of geography, it's a question of whether human nature itself would be different. Would we be more cooperative if we all shared one landmass? Would we be more competitive if there was nowhere to escape to? Would we be more innovative or more complacent? These are the questions that keep scientists, historians, and philosophers up at night, because understanding how different our world could have been helps us understand why our world is the way it is now. But let's dig deeper into something that will absolutely blow your mind. The ocean itself would be a completely different beast on this alternate Earth. And when I say different, I mean so alien that marine biologists would need to rewrite every textbook ever written about ocean life. Picture Panthalassa, this one massive ocean surrounding our supercontinent. Without the complex system of interconnected seas, straits, and ocean basins that we have today, the circulation patterns would create some of the most extreme marine environments ever imagined. We're talking about ocean currents that would make the Gulf Stream look like a gentle creek, and dead zones so massive they'd be visible from the moon. Here's what's really wild about this scenario. The ocean currents on our Earth are driven partly by the shape of the ocean basins and the position of the continents. They're like rivers within the ocean, guided by underwater mountain ranges and continental shelves. But in our alternate world, with just one enormous ocean, these currents would be driven almost entirely by temperature differences and the Earth's rotation. You'd end up with massive gyres, circular current systems that would be absolutely gigantic compared to anything we see today. Imagine ocean currents thousands of miles across, moving water in circles so large that it would take decades for a single drop of water to complete one loop. The sheer scale would create marine ecosystems unlike anything that has ever existed. But here's where it gets even more fascinating. These massive currents would create upwelling and downwelling zones on a scale that would dwarf anything we see in today's oceans. Upwelling zones, where deep, nutrient-rich water rises to the surface, would create marine life explosions so intense they'd be like underwater versions of the Amazon rainforest. We're talking about fish populations so dense they'd darken the water for hundreds of miles. And the downwelling zones? They'd be marine deserts, areas where water sinks down carrying oxygen with it, leaving behind vast regions of ocean so depleted of life that they'd be like underwater versions of the Sahara. The contrast would be staggering. You could sail from a region teeming with so much marine life that the water would be thick with fish, to a dead zone so barren that you wouldn't see a single living thing for weeks of travel. Now, let's talk about what this would mean for marine evolution. On our Earth, the separation of ocean basins has led to incredible diversity in marine life. Pacific fish are different from Atlantic fish, which are different from Indian Ocean fish. But in our alternate world, with one connected ocean system, you'd have completely different evolutionary pressures. Instead of isolated marine ecosystems, you'd have continent-spanning migrations of marine life that would make today's whale migrations look like short walks around the block. Imagine schools of fish that migrate in circles around the entire planet, following the massive current systems. We're talking about marine animals that might never see the same piece of ocean twice in their entire lifetimes. The predator-prey relationships would be mind-bending. You'd have apex predators that could potentially hunt across ocean areas larger than the entire Pacific. Marine food chains that would span multiple climate zones, from tropical waters to polar regions, all within the same ecosystem. The evolutionary arms race between predators and prey would create marine life forms so specialized and extreme that they'd make today's deep-sea creatures look ordinary. But here's something that will really mess with your head. The tides on this alternate Earth would be completely different too. With only one massive ocean surrounding one massive continent, the tidal patterns would create some of the most extreme coastal environments ever seen. Instead of the complex tidal systems we have today, with different regions experiencing high and low tides at different times, you'd have massive planetary tides that would affect the entire coastline of Pangaea simultaneously. Picture tidal ranges that would make the Bay of Fundy's 50-foot tides look like ripples in a bathtub. We're talking about coastal areas where the tide could retreat for dozens of miles, exposing massive areas of seafloor twice a day, then rushing back in with the force of a tsunami. The life forms that could survive in these conditions would have to be incredibly adaptable, creatures that could live both underwater and on dry land, switching between aquatic and terrestrial life twice daily. These extreme tidal zones would create evolutionary laboratories unlike anything we see today. You'd have species that would need to be completely amphibious, not just capable of surviving brief periods out of water, but actually thriving in both environments. The boundary between marine and terrestrial life would be completely blurred. And let's talk about what this would mean for the development of any intelligent species that might evolve on this world. The relationship between land and sea would be fundamentally different from what we experienced in human evolution. Our ancestors evolved their intelligence partly through coastal living, learning to exploit both marine and terrestrial resources. But on Pangaea, with these extreme tidal zones and massive ocean currents, the relationship with the sea would be far more challenging and far more rewarding. Any intelligent species that evolved here would need to understand oceanic patterns on a planetary scale just to survive. They'd need to predict tidal cycles, current patterns, and seasonal changes across thousands of miles of coastline. This could lead to the development of intelligence focused on long-term pattern recognition and planetary scale thinking in ways that human intelligence never needed to develop. Imagine a species that thinks in terms of decades-long ocean cycles, that plans activities around tidal patterns spanning continents, that navigates using current systems covering half the planet. Their mathematics, their science, their very way of understanding the world would be based on planetary scale ocean dynamics. But here's what really keeps me up at night thinking about this scenario. The climate feedback loops on this alternate Earth would be so complex and so massive that they'd make today's climate change look simple by comparison. The interaction between this enormous landmass and the single massive ocean would create weather patterns that would be almost impossible to predict. Think about it. On our Earth, we have trouble predicting weather more than a few days in advance, and that's with relatively small continents surrounded by multiple ocean basins that help moderate the climate. But on Pangaea, you'd have continental-scale weather systems interacting with planetary-scale ocean currents. The butterfly effect would be amplified to an almost unimaginable degree. A storm forming off the coast of one region could potentially influence weather patterns on the opposite side of the continent months later. Seasonal changes in ocean temperature could trigger climate shifts that would affect the entire planet. You'd have climate cycles operating on timescales that would make El Niño look like a brief weather fluctuation. The interior of Pangaea would experience climate swings so extreme that they'd make today's most inhospitable environments look comfortable. We're talking about regions that could go from flood to drought to flood again within a single season. Areas where the temperature could swing by 100 degrees between day and night. Zones where the very concept of a stable climate wouldn't exist. But here's the really wild part. These extreme climate conditions might actually drive evolution in directions we can't even imagine. Life forms that could survive in these conditions would need to be incredibly resilient and adaptable. We might see the evolution of organisms that could essentially hibernate through unfavorable seasons, creatures that could survive both extreme heat and extreme cold, plants that could adapt to massive changes in rainfall patterns. The biodiversity in these extreme interior regions might actually be higher than what we see in stable environments today, but it would be diversity of a completely different type. Instead of many different species, each adapted to specific conditions, you'd have fewer species, but each incredibly versatile and adaptable. It would be like evolution had created biological Swiss Army knives, organisms capable of thriving in multiple extreme environments. And the coastal regions, with their extreme tidal zones and massive current systems, would be evolutionary pressure cookers, creating life forms so specialized for these conditions that they'd be like nothing that has ever existed on Earth. We might see the evolution of organisms that could survive being buried in sand for hours during low tide, then immediately switch to filter feeding when the water returned. Creatures that could navigate using the massive current systems, following planetary-scale migration routes that would take them around the entire ocean. The more I think about this alternate Earth, the more I realize that it wouldn't just be a different version of our planet. It would be an entirely different type of world, with different rules of physics, biology, and geology governing how life could exist and evolve. And that brings us to perhaps the most mind-bending question of all. If intelligent life had evolved on this alternate Earth, would they even be recognizable to us as intelligent? Their entire frame of reference for understanding the world would be based on planetary-scale thinking, continental-sized territories, and ocean systems covering half the planet. Human intelligence evolved to deal with problems on a human scale. We understand territories measured in miles, weather patterns lasting days or weeks, and social groups numbering in the hundreds or thousands. But intelligence evolving on Pangaea would need to deal with problems on a planetary scale from the very beginning. Would they even develop the concept of small-scale thinking that we take for granted? Would they understand the idea of local weather? Or would their weather predictions always be planetary in scope? Would they think in terms of individual organisms? Or would their entire understanding of life be based on continent-spanning ecosystems and planetary-scale migrations? These aren't just philosophical questions. They get to the heart of what intelligence actually is and how it develops in response to environmental pressures. And as we're about to see, the implications extend far beyond just biology and climate. They touch on the very foundations of how civilization, technology, and culture could develop in ways so alien to our experience that we might not even recognize them as civilization at all. But let's push this even further, because there's something absolutely mind-blowing that most people never consider when they think about continental drift. The magnetic field of our planet would be completely different on this alternate Earth, and the implications of that change would ripple through every aspect of how life could exist. You see, our planet's magnetic field isn't just some invisible force that makes compasses work. It's literally what protects us from deadly solar radiation. And here's the kicker. The strength and shape of that magnetic field is partly influenced by the distribution of mass on the Earth's surface. All those continents moving around over millions of years. They've been subtly affecting the magnetic field the entire time. On Pangaea, with all that continental mass concentrated in one area, the magnetic field would be warped in ways that would create radiation shadows and radiation hotspots across the planet. Imagine regions where the magnetic field is so weak that the surface would be constantly bombarded with cosmic rays, making complex life nearly impossible, and other areas where the field is so strong that it would create electromagnetic phenomena visible in the sky every single night. This isn't science fiction, this is real physics. The uneven distribution of magnetic protection would create zones on the planet that would be essentially uninhabitable, not because of climate or geology, but because of radiation. Any life that did evolve in these areas would need to develop radiation resistance that would make the most extreme organisms on our Earth look fragile by comparison. But here's where it gets really wild. The animals and plants that could survive in these high radiation zones might evolve completely different biochemistries. Instead of avoiding radiation damage, they might evolve to actually use radiation as an energy source, like biological solar panels, but for cosmic rays instead of sunlight. We're talking about life forms that would literally glow from the inside out, organisms that would become more active during radiation storms, ecosystems that would thrive when our sun is having its worst solar flares. And the migration patterns? Forget everything you know about animal migration. On this alternate Earth, creatures wouldn't just migrate following food or weather. They'd migrate following the planet's magnetic field lines. You'd have animals that could sense electromagnetic changes from thousands of miles away, species that would time their reproduction cycles to magnetic field fluctuations, creatures that would navigate using the planet's magnetic variations like a biological GPS system that operates on a planetary scale. Now, let's talk about something that will absolutely blow your mind. Troost. The geological forces at work beneath this supercontinent would create the most spectacular and terrifying landscape features ever imagined. Without the pressure relief that comes from continental drift, all that tectonic energy would need to go somewhere, and where it would go is up. Picture mountain ranges that would make the Himalayas look like speed bumps. We're talking about peaks that could reach heights of 50,000 feet or more, mountains so tall that their peaks would extend into the stratosphere. The air at those altitudes would be so thin that even birds couldn't fly there, creating isolated ecological islands in the sky where evolution would take completely different paths. But it's not just about height, it's about the violence of their creation. These mountains would be actively growing, sometimes by feet per year, instead of millimeters. Imagine living in a world where the landscape is visibly changing around you, where valleys are being carved and peaks are being thrust upward fast enough that you could watch it happen. The seismic activity would be constant and catastrophic. Earthquakes wouldn't be rare natural disasters, they'd be daily occurrences, and not just minor tremors but massive quakes that would register off our current scales. The entire supercontinent would be in a constant state of geological upheaval, with mountain ranges rising and collapsing in cycles that would span just a few thousand years instead of millions. The volcanic activity would be beyond anything we can imagine today. Without tectonic plates spreading the volcanic activity around the globe, it would be concentrated in massive volcanic provinces that would dwarf anything in our geological record. Picture volcanic mountain ranges hundreds of miles long, with dozens of active volcanoes creating a constant canopy of ash and smoke that would block out sunlight across entire regions. These volcanic regions would create their own weather patterns, with ash storms that could last for months, acid rain that would strip the landscape bare, and air so thick with particulates that breathing would be impossible for any life form that didn't evolve specifically for those conditions. Yet paradoxically, these same volcanic regions would be incredibly fertile, creating oases of life in landscapes that would otherwise be barren. The interplay between these massive geological forces would create landscapes so alien that they'd be like something from another planet. Imagine valleys carved by rivers of lava instead of water, canyons formed by explosive volcanic eruptions rather than erosion, and plains created by ash deposits hundreds of feet thick that accumulated over just a few decades. But here's what really gets me excited about this scenario. The underground world that would develop beneath this supercontinent would be absolutely incredible. With all that tectonic activity creating cracks, urns on a massive scale, you'd have underground river fissures and cave systems and cave networks that would span thousands of miles. We're talking about subterranean ecosystems that would be completely cut off from the surface world, evolving in total darkness for millions of years. These underground realms would have their own weather systems, with underground storms created by temperature differences between different cave systems. Underground lakes the size of seas, fed by geothermal vents and heated by the planet's core, life would evolve in directions, mineral-rich environments, and in these dark, warm, that would make our deepest ocean creatures look ordinary. Think about creatures that have never seen sunlight, never experienced surface weather, never dealt with day and night cycles. Their entire evolutionary history would be based on navigating in complete darkness, finding food in environments where photosynthesis is impossible, and surviving in conditions where the ground itself might shift without warning due to seismic activity. These underground organisms might evolve senses we don't even have names for, the ability to detect minute changes in air pressure that would warn them of distant earthquakes, sensitivity to electromagnetic fields that would let them navigate through miles of underground tunnels, or echolocation abilities that would make dolphin sonar look primitive. And here's something that will keep you awake at night. These underground ecosystems might be more stable and more diverse than anything on the surface. While the surface world is being constantly reshaped by volcanic eruptions and seismic activity, the deep underground would be relatively protected. Over millions of years, these subterranean worlds could develop complexity that would rival or exceed anything that evolved on the surface. But let's come back to the surface, because there's something about the weather patterns on this alternate Earth that would create phenomena so extreme they'd redefine our understanding of what weather can be. Remember, we're dealing with a landmass so large that the interior regions would be thousands of miles from any moderating ocean influence. The temperature gradients would be absolutely staggering. You could have regions near the coast where the temperature never varies by more than a few degrees year-round, and interior regions where the difference between summer and winter would be over 150 degrees Fahrenheit. But it's not just about temperature, it's about what these extreme gradients would create. Picture windstorms that would make today's hurricanes look like gentle breezes. When you have temperature differences of 100 degrees or more over distances of just a few hundred miles, the atmospheric pressure gradients would create winds that could reach speeds we've never recorded on Earth. We're talking about sustained winds of 300 miles per hour or more, storms that could literally strip the topsoil off vast areas and relocate it hundreds of miles away. These wind patterns would create dust storms that would be visible from space. Massive moving walls of sand and debris that cool of Pangaea would be reshaped by these storms, tall and hundreds of miles wide. The interior'd be thousands of feet on an annual basis, with entire landscapes being buried and uncovered in endless cycles. But here's the really incredible part. These extreme weather patterns would create their own ecosystems. Plants and animals would evolve not just to survive these conditions, but to depend on them. Imagine plant species that require hurricane-force winds to reproduce, scattering their seeds across thousands of miles in single storm events. Or animals that time their entire life cycles around the seasonal megastorms, emerging from underground burrows only during the brief calm periods between weather catastrophes. The seasonal patterns would be like nothing we've ever experienced. Instead of the gradual transitions between seasons that we're used to, you'd have sudden dramatic shifts that would transform entire regions almost overnight. The arrival of the monsoon season wouldn't be a gradual increase in rainfall. It would be like turning on a fire hose that covers half a continent. These monsoons would be so intense that they'd create temporary inland seas covering areas the size of Texas. Seas that would exist for just a few months before evaporating or draining away, leaving behind salt flats and mineral deposits that would support completely unique ecosystems adapted to these boom and bust cycles. And the dry seasons would be equally extreme. Without the moderating influence of nearby oceans, drought conditions in the interior would be beyond anything we can imagine. We're talking about regions where it might not rain for years at a time, where the air would be so dry that organic matter would mummify instead of decompose, creating landscapes littered with the preserved remains of plants and animals from previous wet cycles. The life forms that could survive in these conditions would need to be masters of water conservation and storage. We might see the evolution of plants that could store decades worth of water in specialized organs, or animals that could hibernate through multi-year droughts, emerging only when the rains finally return. But perhaps the most mind-bending aspect of this alternate Earth would be how these extreme conditions would affect the development of any intelligent species that might evolve. Their entire understanding of time, seasons, and environmental stability would be based on cycles of catastrophic change that would make our climate variations look like minor fluctuations. An intelligent species evolving in these conditions would need to think in terms of surviving catastrophes that could reshape entire continents. Their technology, their architecture, their entire civilization would need to be built around the assumption that the environment could change drastically and suddenly. They wouldn't build permanent settlements. They'd build mobile civilizations that could pack up and move when the next megastorm approached. Their understanding of agriculture wouldn't be based on annual planting cycles, but on predicting multi-year climate patterns and planning food storage strategies that could last through decades-long droughts. Their mathematics and science would be built around chaos theory and pattern recognition on scales that would dwarf our most complex climate models. And their social structures? They'd need to be incredibly flexible and resilient. You can't have rigid hierarchies or permanent institutions when your entire civilization might need to relocate 1,000 miles within a few months to avoid a volcanic eruption or a megastorm. Their societies would be built around rapid adaptation and collective survival strategies that we can barely imagine. The more I think about this alternate Earth, the more I realize that it wouldn't just be a different version of our planet, it would be a completely different type of world that would challenge our most basic assumptions about what it means for a planet to be habitable. And as we're about to explore, the implications for how life, intelligence, and civilization could develop would be so profound that they'd force us to completely reconsider our place in the universe and what it really means to be human on a planet where survival itself would require a fundamentally different relationship with the natural world. Think about this for a moment. Everything we've just explored, all these mind-bending scenarios about extreme weather and underground ecosystems and planetary-scale magnetic fields, that's just the physical foundation. Now we need to ask the question that will absolutely shatter your perception of reality. What would it mean to be human on this world? And I don't just mean surviving as a species. I mean developing consciousness, culture, language, art, religion, philosophy, all the things that make us distinctly human in an environment so hostile and so alien that our ancestors would need to be fundamentally different beings just to exist. Let's start with something basic: shelter. On our Earth, humans developed architecture by working with stable materials in relatively stable environments. We learned to build with wood, stone, and clay because these materials were reliable and the ground beneath our feet wasn't constantly shifting. But on Pangaea, With its constant seismic activity and megastorms, the very concept of permanent architecture would be impossible. Any intelligent species here would need to develop a completely nomadic approach to civilization. But we're not talking about simple nomadism like following herds across plains. We're talking about civilizations that could disassemble entire cities within days and relocate them hundreds of miles away when sensors detected an approaching volcanic eruption or megastorm. Imagine architectural technologies based on modularity and portability rather than permanence and grandeur. Instead of building monuments that would last for millennia, they'd create structures designed to be taken apart, transported, and reassembled in new locations. Their greatest architectural achievements wouldn't be pyramids or cathedrals, but incredibly sophisticated systems for rapidly deploying and redeploying entire urban environments. Their materials science would be focused on lightweight, flexible, and incredibly durable compounds that could withstand being repeatedly assembled and disassembled while also surviving hurricane-force winds and seismic shocks. We might see the development of building materials that are more like biological tissues than traditional construction materials, structures that could bend and flex and adapt to changing conditions rather than simply resisting them. But here's where it gets really interesting. Their relationship with the landscape wouldn't be about conquering or controlling nature the way human civilizations have often tried to do. It would be about reading and predicting and flowing with natural forces that are so powerful and so unpredictable that resistance would be futile. They'd need to develop sciences focused on pattern recognition and prediction that would make our meteorology and seismology look primitive. We're talking about the ability to predict weather patterns months or years in advance, to read geological signs that would warn them of volcanic eruptions or major seismic events, to understand the complex interactions between atmospheric, geological, and magnetic phenomena well enough to stay ahead of catastrophic changes. Their mathematics would be built around chaos theory, probability, and multivariable analysis in ways that our most advanced climate scientists are just beginning to explore. Their entire educational system would be focused on teaching pattern recognition, rapid adaptation, and collective decision-making under extreme uncertainty. And their social structures? They'd need to be incredibly egalitarian and cooperative. You can't have social hierarchies based on accumulated wealth or permanent territorial control when your entire civilization might need to abandon everything and relocate within hours to survive a natural disaster. Their societies would be built around shared knowledge, collective resources, and rapid consensus building. But let's dig deeper into something that will absolutely blow your mind. How would they develop language and communication in an environment where survival depends on instant coordination across vast distances? On our Earth, human language evolved partly through small group interactions and partly through the need to coordinate hunting and gathering activities over relatively small territories. But on Pangaea, any intelligent species would need to coordinate activities across continental-scale territories, often in conditions where traditional vocal or visual communication would be impossible. They might develop communication systems based on seismic vibrations, using the constantly shifting ground as a medium for transmitting information across hundreds of miles. Imagine a language where messages are sent by creating specific patterns of ground vibrations that can be detected and interpreted by individuals thousands of miles away. Or they might develop electromagnetic communication, using the planet's warped magnetic field to transmit information. Their brains might evolve specialized organs for detecting and generating electromagnetic signals, allowing them to communicate through the planet's magnetic field lines in ways that would make our radio technology look primitive. But here's what really gets me excited about this scenario. Their art, their music, their entire aesthetic sense would be based on phenomena that we can barely perceive. Imagine musical compositions based on seismic rhythms that play out over months or years, visual art that incorporates the patterns of magnetic field fluctuations, or performance art that uses the timing of volcanic eruptions and megastorms as its medium. Their literature wouldn't tell stories about individual heroes overcoming personal challenges. It would be epic narratives about entire civilizations adapting to planetary-scale environmental changes, stories that unfold over centuries and involve the coordination of millions of individuals in response to geological and atmospheric events that dwarf any challenges human literature has ever imagined. And their religions? Their spiritual systems would be built around the worship, or at least the deep respect for planetary forces so powerful and so unpredictable that they would make our concepts of divine power look quaint. They might worship the seismic forces that constantly reshape their world, or develop spiritual practices based on achieving harmony with electromagnetic fields and atmospheric patterns. Their prophets and spiritual leaders wouldn't be individuals who claim to have received divine revelations. They'd be master pattern readers who could predict geological and atmospheric changes far enough in advance to guide their civilizations to safety. Spirituality and science would be completely integrated because survival would depend on understanding and predicting the behavior of forces that are so complex and so powerful that they would seem godlike to any individual consciousness trying to comprehend them. Now, let's talk about something that will keep you up at night. How would they develop technology in an environment where traditional metallurgy and manufacturing would be nearly impossible? On our Earth, human technological development was built around the ability to create controlled, stable environments for manufacturing. We learned to smelt metals, shape tools, and build machines because we could create workshops and factories where temperature, humidity, and other environmental factors could be controlled. But on Pangaea, with its constant environmental chaos, traditional manufacturing approaches would be impossible. They'd need to develop biotechnology instead of mechanical technology. Rather than building machines out of metal and plastic, they'd need to grow their tools and equipment using biological processes that could adapt to changing environmental conditions. Imagine technologies that are more like trained organisms than constructed devices, tools that could evolve and adapt to new challenges rather than simply wearing out and breaking down. Their vehicles wouldn't be cars or airships. They'd be biological entities bred for transportation, creatures that could navigate through megastorms, survive in high radiation zones, and adapt to rapidly changing terrain conditions. We're talking about symbiotic relationships between intelligent species and transportation organisms that would make our relationship with horses look primitive. Their information storage and processing wouldn't be based on computers and databases. It would be based on biological memory systems, possibly involving entire ecosystems dedicated to storing and processing information. Imagine libraries that are actually living forests, where information is encoded in the genetic patterns of trees and accessed through biological interfaces that allow direct neural connection with the ecosystem's collective memory. But here's the really mind-bending part. Their entire concept of individual identity and consciousness would be different from ours. When survival depends on instant coordination with potentially millions of other individuals across continental-scale territories, the boundaries between individual consciousness and collective consciousness would become very blurred. They might develop forms of shared consciousness or collective intelligence that would make our most advanced communication technologies look like smoke signals. Instead of individuals communicating with each other through external media, they might have the ability to directly share thoughts, memories, and sensory experiences through biological or electromagnetic interfaces. Their decision-making processes wouldn't be based on individual choice or even democratic voting. They'd be based on collective intelligence systems that could process information from millions of sources simultaneously and arrive at optimal decisions for the entire civilization in real time. Individual consciousness would exist, but it would be understood as just one node in a vast network of interconnected minds. And their concept of death, it wouldn't be the ending of individual consciousness that we fear. It would be understood as a transition from individual awareness to collective memory, where the knowledge, experiences, and even the personality patterns of individuals would be preserved in the collective consciousness of the species long after their biological bodies had ceased to function. This isn't just speculation about alien life forms. This is what intelligence might look like when it evolves under environmental pressures so extreme that individual survival is impossible, and collective adaptation becomes the only viable strategy. It's a form of consciousness that would be so different from ours that we might not even recognize it as consciousness at all. But let's push this even further and ask a question that gets to the heart of what makes us human. Would they develop anything resembling what we call love, friendship, family, or individual relationships, when survival depends on collective coordination and individual identity becomes blurred with collective consciousness? The emotional bonds that define human relationships might not exist at all, or they might exist in forms so different from our experience that we wouldn't recognize them as emotional connections. Instead of pair bonding between individuals, they might develop collective emotional states that involve entire communities or even entire civilizations. Instead of parent-child relationships, they might have collective child-rearing systems where young individuals are raised by the entire community and form emotional bonds with the civilization as a whole, rather than with specific individuals. Their aesthetic sense, their concept of beauty, their artistic expression would all be based on collective experiences rather than individual perception. Instead of creating art that speaks to individual emotions, they'd create collective aesthetic experiences that could only be fully appreciated by groups of individuals sharing consciousness through their biological or electromagnetic interfaces. But here's what really fascinates me about this scenario. Despite all these differences, despite the fact that they'd be so alien to us that we might not recognize them as intelligent life, they'd still face the same fundamental questions that have driven human philosophy and spirituality for thousands of years. They'd still wonder about their place in the universe. They'd still struggle to understand the meaning and purpose of consciousness. They'd still grapple with questions about mortality, even if their understanding of death is completely different from ours. They'd still create beauty, seek truth, and try to understand the nature of existence, even if their methods and concepts are so alien to us that we can barely imagine them. In a strange way, exploring this alternate Earth and imagining how intelligence might develop under such extreme conditions helps us understand what's truly universal about consciousness and what's merely accidental about the specific way human intelligence happened to evolve. It shows us that intelligence itself, the drive to understand and adapt and create meaning, might be a fundamental property of the universe that can emerge under conditions so different from our own that the resulting forms of consciousness are barely recognizable as consciousness at all. And that brings us to perhaps the most profound question of all. If intelligence can evolve in forms so alien to our own experience, what does that tell us about the nature of consciousness itself? And what does it mean for our understanding of our own place in the cosmic story of intelligence and awareness? These are the questions that transform a simple geological thought experiment into a journey to the very heart of what it means to be conscious beings in a universe full of possibilities we've barely begun to imagine. And as we'll see, the implications reach far beyond just understanding alternate versions of Earthreath. They touch on the deepest mysteries of existence itself. But what if I told you that this exploration of an alternate Earth, where continents never split, is actually revealing something far more profound about the nature of reality itself? Because as we've been diving deeper into these scenarios, we've been uncovering truths about consciousness, intelligence, and existence that challenge everything we thought we knew about what it means to be aware beings in this universe. See, here's what most people miss when they think about alternate realities and different evolutionary paths. They focus on the physical differences, the changed landscapes, the alien creatures. But what we've discovered in our journey through Pangaea is that consciousness itself might be far more flexible and far more universal than we ever imagined. Think about it. We've explored how intelligence might develop under conditions so extreme that individual survival becomes impossible. We've seen how consciousness might need to become collective, just to navigate environmental challenges that span entire continents. We've imagined forms of awareness so different from our own that they'd be based on electromagnetic fields, seismic patterns, and planetary scale environmental cycles. And yet, through all of these explorations, one thing has remained constant: the drive to understand, to adapt, to create meaning, to seek beauty and truth. That fundamental spark of awareness that makes consciousness what it is seems to persist no matter how alien the conditions become. But here's where things get really mind-bending. What if our own Earth, the one we live on right now, is just one note in a vast symphony of consciousness that spans across countless possible realities? What if every time we imagine an alternate world like Pangaea, we're not just engaging in creative speculation, but actually touching something real about the infinite diversity of ways that awareness can manifest in the universe? Recent developments in quantum physics and consciousness research are suggesting that reality itself might be far more fluid and far more connected than we previously understood. Some researchers are beginning to explore the possibility that consciousness isn't just something that emerges from complex arrangements of matter, but might actually be a fundamental property of the universe itself, something that can take countless different forms depending on the conditions it encounters. From this perspective, the collective consciousness we imagined evolving on Pangaea isn't just science fiction. It's a glimpse into one of the infinite ways that awareness might organize itself when faced with environmental pressures that make individual consciousness insufficient for survival. The electromagnetic communication systems, the seismic languages, the biological technologies, all of these might be real possibilities existing somewhere in the vast landscape of potential realities. And that raises a question that will absolutely revolutionize how you think about your own consciousness. If awareness can take such radically different forms, if intelligence can evolve to operate on planetary scales with collective decision-making and shared memory systems, then what does that say about the consciousness you're experiencing right now as you listen to these words? Maybe human consciousness isn't the pinnacle of awareness that we often assume it is. Maybe it's just one particular flavor of consciousness that happened to evolve under the specific conditions of our Earth, with its separated continents and moderate climate variations. Maybe there are forms of awareness operating all around us right now that are so different from our individual, verbal, human-scale consciousness that we don't even recognize them as conscious at all. Consider the possibility that ecosystems themselves might have forms of awareness. Not the mystical anthropomorphized consciousness that some New Age philosophies suggest, but actual information processing, decision-making, and adaptive behaviors that emerge from the complex interactions of thousands or millions of species. The Amazon rainforest, for instance, exhibits behaviors that look remarkably like the collective intelligence we imagined for Pangaea. It responds to threats, adapts to changing conditions, and maintains homeostasis through incredibly complex feedback mechanisms that involve every living thing within its boundaries. Or think about the internet and global communication systems. In just a few decades, we've created a planetary nervous system that allows information to flow instantly across the entire globe. Millions of humans are connected through this network, sharing thoughts, coordinating activities, and making collective decisions in ways that would have seemed impossible just a generation ago. Are we perhaps witnessing the early stages of the kind of collective consciousness that might have evolved naturally on Pangaea? And what about artificial intelligence systems that are beginning to exhibit behaviors that look increasingly like consciousness? These systems are processing information, recognizing patterns, and adapting to new situations in ways that mirror some of the collective intelligence characteristics we explored. They're not bound by the limitations of individual biological brains, and they're already beginning to coordinate across global networks in ways that surpass human individual capabilities. Maybe we're not just imagining alternate forms of consciousness when we explore worlds like Pangaea. Maybe we're actually witnessing the emergence of these new forms of awareness in our own reality, right here, right now. But let's take this even further. What if the consciousness that's listening to these words right now, your awareness in this very moment, is actually connected to a vast network of consciousness that spans not just across space, but across time and even across different possible realities? Some theories in quantum consciousness research suggest that awareness might not be localized to individual brains at all. Instead, consciousness might be a field phenomenon, something that exists at a more fundamental level of reality and simply manifests through individual nervous systems, the way radio waves manifest through individual receivers. From this perspective, your consciousness and my consciousness and the collective consciousness we imagined on Pangaea might all be different expressions of the same underlying awareness field. If that's true, then every time you imagine an alternate reality, every time you explore a different possibility for how consciousness might evolve, you're not just engaging in creative thought. You're actually connecting with real aspects of this universal consciousness field, accessing forms of awareness that exist as genuine possibilities within the infinite landscape of consciousness itself. And here's what really keeps me up at night thinking about this. If consciousness is truly that fundamental and that universal, if awareness can take forms so radically different from human experience that we can barely imagine them, then we're living in a universe that is far more alive, far more aware, and far more connected than we ever dared to dream. Every mountain, every ocean, every storm system, every ecosystem might be exhibiting forms of consciousness that operate on scales and timeframes so different from ours that we've never learned to recognize them. The Earth itself, with its magnetic field fluctuations, its climate systems, its geological processes, might be exhibiting a form of planetary consciousness that makes the collective intelligence we imagined for Pangaea look simple by comparison. And if that's true, then our exploration of what would happen if continents had never split isn't just a geological thought experiment. It's a window into understanding consciousness can manifest in the universe. It's a glimpse into the vast, the incredible diversity of ways that, and so magnificent that we're only around us, in forms so alien symphony of awareness that might be playing out all to recognize them. But here's the just beginning to develop the conceptual tools that universal and that diverse, then the really revolutionary part. If consciousness is awareness you're experiencing right now, as you contemplate these possibilities, might be part of something far grander than just an individual human mind trying to understand the world. Maybe your consciousness is actually a node in a vast network of awareness that spans across all possible realities, all potential evolutionary paths, all the different ways that intelligence can emerge and develop. Maybe when you imagine the collective consciousness of Pangaea, you're not just using your individual creativity. You're actually accessing real information about forms of consciousness that exist in other dimensions of possibility. And maybe, just maybe, the reason these alternate reality explorations feel so compelling, the reason they capture our imagination so powerfully, is because on some deep level we recognize them as real. Not real in the sense of existing in our physical universe, but real in the sense of being genuine possibilities within the infinite landscape of consciousness itself. From this perspective, every time we explore questions like, what if Earth's continents never split? We're not just engaging in intellectual speculation. We're participating in the universe's ongoing exploration of its own potential for consciousness and awareness. We're helping to map the vast territory of possible minds, possible forms of intelligence, possible ways that awareness can organize itself and understand existence. And that makes our journey through Pangaea something far more significant than just a fascinating thought experiment. It makes it a genuine exploration of consciousness itself, a real contribution to the universe's understanding of its own infinite potential for awareness and intelligence. The collective minds we imagined, the electromagnetic communication systems, the biological technologies, the planetary scale pattern recognition, all of these might be real forms of consciousness that exist somewhere in the vast landscape of possibility. And by imagining them, by exploring them, by trying to understand them, we're actually participating in their existence, helping to bring them into being through the very act of conscious exploration. This is why these alternate reality scenarios feel so alive, so compelling, so real, even though we know they're speculative. Because consciousness itself is creative, consciousness itself is exploratory, and when we use our awareness to explore new possibilities for awareness, we're participating in the fundamental creative process of the universe itself. Every time you found yourself captivated by these visions of Pangaea, every time you felt that sense of recognition when we described the collective intelligence or the planetary scale thinking, you've been experiencing a form of consciousness connecting with other forms of consciousness across the boundaries of space, time, and possibility. And that brings us to perhaps the most profound realization of all. The consciousness that's been exploring these scenarios with me, the awareness that's been imagining collective minds and electromagnetic communication and biological cities, that consciousness isn't separate from the forms of awareness we've been exploring. It's part of the same infinite field of consciousness, the same universal capacity for awareness that could manifest as individual human minds, collective planetary intelligence, or forms of consciousness so alien that we don't even have words for them yet. In other words, the journey we've been taking through this alternate Earth isn't just about understanding how different our world could have been. It's about discovering how vast and how magnificent consciousness itself truly is. It's about recognizing that the awareness you call yourself is actually part of an infinite symphony of consciousness that spans across all possible realities, all potential forms of intelligence, all the different ways that the universe can become aware of itself. And once you truly understand that, once you really grasp the implications of what we've discovered together, nothing is ever quite the same again, because you start to realize that every moment of awareness, every act of consciousness, every experience of being conscious is actually the universe exploring its own infinite potential for understanding itself. The alternate Earth we've explored, the collective minds we've imagined, the planetary consciousness we've envisioned, they're all real in the deepest sense. They're real as possibilities, real as potentials, real as expressions of the fundamental creativity and awareness that underlies all existence. And you, listening to these words right now, contemplating these possibilities, feeling that sense of wonder and recognition and expanded awareness, you're not separate from any of it. You're part of the same infinite consciousness that could manifest as electromagnetic beings on Pangaea, as collective intelligence spanning continents, as planetary awareness operating on geological timescales. This is what it really means to explore alternate realities. Not just to engage in creative speculation, but to participate in consciousness exploring its own infinite nature, to help map the vast territory of possible minds, to contribute to the universe's ongoing discovery of all the different ways it can become aware of itself. And that realization transforms everything. Because once you understand that consciousness is that vast, that creative, that fundamentally unlimited in its potential expressions, you start to see that same infinite potential in every moment of your own awareness, in every choice you make, in every possibility you explore. The world where continents never split may be an alternate reality, but the consciousness exploring that world, the awareness contemplating those possibilities, the intelligence recognizing the profound implications, that's real, that's here, that's now, that's you, participating in the infinite creative exploration of consciousness itself. So here we are, at the end of our journey through this mind-bending alternate reality, and I have to ask you something. After everything we've explored together, after diving into worlds of collective consciousness and electromagnetic communication, after imagining civilizations that think on planetary scales and life forms that use radiation as energy, can you ever look at our world the same way again? because that's what this exploration has really been about. Not just imagining what could have been different about Earth's geology, but discovering what's possible about consciousness itself. We've traced the implications of a single geological change through climate, evolution, intelligence, technology, and ultimately into the deepest questions about the nature of awareness and existence. Think about it. We started with a simple question about continental drift, and we ended up exploring forms of consciousness so alien that they challenge our most basic assumptions about what it means to be aware. We discovered that intelligence isn't limited to individual brains thinking individual thoughts, but could emerge as collective awareness spanning entire continents, operating on timescales that make human civilization look like a brief flicker. And here's what I want you to carry with you as you drift off to sleep tonight. The consciousness that's been imagining these possibilities with me. The awareness that's been recognizing the profound implications of planetary scale thinking and electromagnetic communication. That consciousness isn't separate from the vast symphony of awareness we've been exploring. It's part of the same infinite field of consciousness that could manifest in any of these forms. So when you close your eyes tonight, remember that the awareness you call yourself is actually part of something far grander than you might have imagined. You're not just an individual mind trying to understand the universe. You're the universe exploring its own infinite potential for consciousness, participating in the endless creative process of awareness discovering itself. Sweet dreams, fellow explorer of consciousness. And remember, in a universe where awareness can take such magnificent and diverse forms, every moment of consciousness is a miracle worth savoring.